Hi everyone, welcome to Miss Sawagid's math class. Before we start today's lesson, let me ask you this question. Have your parents ever walked to your room and they saw your pants, your clothes, your shoes, even your toys on the ground, they all scattered everywhere, and they got mad at you and asked you to clean it up? I'm sure this happened. But today's lesson is not about the mess in your room. It's a math class and it talks about a scatter plot. So what is a scatter plot in math? So scatter plot in math is when you have a coordinate plane and you have dots on that coordinate plane and they are scattered everywhere. But how are they scattered? Is there a trend between the distance, which is the y-axis, and the time, which is the x-axis? What's happening to the distance over time? Is there a trend? Is there a pattern? Is there an association or a correlation, which is the same, between the distance and the time in hours? If you're able to find that correlation or the pattern, then you are asking if there is a relationship between the x value and the y value on a coordinate plane. Now let's describe the scatter plot using those three examples. If you can find a trend, if you can find a pattern, that means there is a relationship between the x and the y values. How can you describe the pattern or that relationship in a scatter plot? Three things we talk about. The first one is strength, whether that relationship is strong or weak. The second thing we talk about is direction, whether this relationship is positive or negative. And the last thing we talk about, whether that relationship is linear or nonlinear. Let's discuss this first example. I can tell there is a trend, there's a pattern, just like ants going uphill. So this scatter plot shows a relationship, and the relationship is strong because all these dots on the scatter plot are close to each other. It's positive because it's going up from left to right, and it is linear because it made a thick line. So as x value increase, the y value will increase too. That's what positive relationship means. Both values will increase. Now let's talk about the second one. Watch how there is a pattern from left to right, it's going down. So all these dots, I can tell that they are going down. So there is a relationship, and that relationship is strong because all these dots are close to each other. It's negative because it's going down, and it created like a thick line. So there is a pattern. It is strong, negative, linear relationship. But when it's negative, that means as the x value increase, the y value will decrease. Now let's talk about the last example. Again, it is a scatter plot, and I can tell that those dots are close to each other, but watch how it curves. So there is a relationship because there is a pattern, but that pattern curves up, which means it is strong, positive relationship, but it's nonlinear. I will add one more last example to this. Look at this scatter plot on the top. Watch how the dots are scattered everywhere. What does that mean? Is there a relationship? Is there a correlation? Is there a pattern? Since the dots are scattered everywhere, I can't tell what the relationship is. Therefore, there's no pattern, no correlation between the x and the y, therefore no relationship whatsoever. And that's the difference between no relationship and if there is a relationship. Here's the first example for today's lesson. The table shows the number of absences and the final grade for students in math class. 2 questions to answer. Plot the data in a coordinate plane and describe the relationship between the absences and your math final grade. Since they gave us a table, the first column always represents the x value and the second column is the y value. For me to plot those dots on the coordinate plane, I need the coordinate pairs. And I can get those coordinate pairs from the table. where x is 0, y is 95, x is 3, y is 88, x is 2, y is 91, and so forth. So I've done this already. Here is the graph where the x represents the day absent and the y represents the final grade. Now we need to find if there is a relationship and describe that relationship. So can you find a pattern? Is there a trend? I can see that the dots are going down from left to right, which means that's a negative linear relationship. Since it's negative, that means one value will increase, the other value will decrease. For us to explain what's happening, let's fill in the blank. As the number of absences increase, the final grade will decrease. Now, did you notice something? Look at the coordinate plane. Do you see that dot all the way on the top of the corner? That coordinate pair is 1196. This is called an outlier. And an outlier does not fit the pattern, which means this person who was absent 11 days scored 96. It's the highest score. It doesn't matter. It doesn't count because it does not fit that pattern. We call it an outlier. It's out of the pattern. Here's another example. Describe the relationship between the television size and price. Is there a relationship between the television size in inches, which is the axis, and the price of the TV, which is the y-axis? Do you find a trend? Do you find a pattern? I do. I can see the dots are going this way, up, which means it's positive and it is linear. To describe the relationship, again, let's fill in the blank. Remember, positive means both values, the x and the y, will increase or both values will decrease. So let's fill in the blank to describe the relationship between the television size and price. As the TV size increase, the TV price will also increase. So they both increased, which means positive. Now, is there an outlier? Look at that green circle over there, which is far away from the data. That's an outlier. Does not fit the pattern. Watch how 70, 2,200, it means the 70-inch TV costs 2,200. That's a bigger TV for a cheaper price. It does not follow that pattern, so we call it an outlier. We're not going to even count it. Another thing to discuss, it's called a cluster. And a cluster is a group of dots on the coordinate plane. Do you see a group of dots that's together on the coordinate plane? I do, which is that red circle. That's called cluster. All these 4 or 5 dots together in that area. The cluster means around 30-inch TV, the price is less than $500. Now, one more thing to describe in a scatter plot, something called a gap. Do you see a gap in the scatter plot? I see that it's going up. I see the outlier. I see the cluster. Gap is a space between those dots. I see the space between $500 and $1,500 for the TV. So to describe a scatter plot, first of all, you need to describe the relationship, whether it's positive or negative, linear or nonlinear. If there's an outlier, cluster, or a gap, you need to identify all these. Here's another example. Describe the relationship between the person's age and number of pets. Identify the gaps, clusters, or outliers. Is there a relationship between the age and the number of pets? Watch how all the dots scattered everywhere. Can you find a pattern? Can you find a trend? I can't. There is no pattern. That means there is no relationship. I cannot conclude that the older the person, the more pets they have, or the younger the person, the more pets they have. It doesn't show that. So there is no pattern, which means there is no relationship. Therefore, there is no outlier, no cluster, no gap. You can't talk about any of this if there is no relationship. Here's the last example for today's lesson. This is also a scatter plot. Watch how there's a trend or a pattern where it goes down and it goes up. It makes a U shape. So there is a pattern, it's just nonlinear. So this scatter plot is strong but non-linear scatter plot. There isn't any outlier, there isn't any gap or a cluster. In conclusion, for the scatter plot, here's the 4 examples that we talked about. The first one, there is a relationship, there is a trend. It's a positive linear. That means both x and y value has the same relationship. They both increase or they both decrease. But when you have a negative linear relationship, that means the value of the x and the y are the opposite. One of them will increase, the other one will decrease. That's what a negative relationship is. Or it could be positive but non-linear because it curves somehow. Or the last example, when the dots are scattered everywhere, there is no relationship. Keep in mind, you can talk about a gap, a cluster, or an outlier only if there is a relationship. If there is no relationship, you can't talk about that. That's it for today's lesson. Thank you so much for liking, subscribing, and commenting on my videos. See you next time and have a great day.